Yeah, so here we go.
Is he supposed to be in there all day?
Yeah, he is.
I thought I just saw him in the hallway earlier.
You know what? They said that to me earlier this morning. Measures of angles is what we're going to start out with. We're going to start the unit of trig. I know you're excited. Trigonometry. You did some of this in geometry, but all you did in geometry was kind of kiss the topic. You didn't get to really delve into all the beauty of trig. So let's talk about what the definition of standard form is. By looking at this picture, I'm going to tell you what I think she wrote over here. You have an angle, and an angle is made up of something called rays. Remember, rays are those segments that go forever in one direction? The vertex of the angle is at the origin of the xy plane, 0, 0. What I want you to do is imagine that those legs of the angle are actually together, laying on the x-axis. When one of those legs decides to open and come out to here, we say that that angle is in standard form, where one of the legs, this leg here, is called the initial position. When the angle opens up and stops, what's another name for stop? Think of a science fiction movie when the guy goes, "I'll be back." Oh, so what kind of, say it again? That's it. This is called the not the Terminator, the terminal. I'm using the word position here. I am pretty sure she calls it the initial side or the terminal side. And let's see what we have notes here. An angle on the coordinate plane is in standard form when the vertex is at the origin. I think I said that. And one ray lies on the positive x-axis. Is that what I said? Yeah. One of the has to be laying on the x? The ray on the x-axis is called the reason I think she had, wrong word. The reason I think she used the word side is because initial position doesn't really sound like a thing. Because he says called the. So I think she meant side, which is true. I said it was in the initial position. The name of that side is called the initial side. The other ray is called Arnold Schwarzenegger, terminal side. If you rotate that leg that is moving to the terminal side counterclockwise, that means you're going backwards on the clock like this. Backwards on the clock. That would result in an angle that is positive. An angle would be positive. If you rotate that side counterclockwise, which means that was, wait, I did it backwards, didn't I?
No, you did it right. No, this is clockwise.
This is clockwise.
Yes, this is clockwise.
And then that's positive. I don't know why I drew it like that. Then this one is counterclockwise.
And that should result in
That would be your negative. Yeah, I can just now see 100 messages in the YouTube saying, hey, you did it wrong. Okay, we did it wrong for 30 seconds. All right, let's talk about degrees. The one angle measurement unit that you should be very familiar with. How many degrees in a circle?
360 degrees.
You mean if my initial side is here and my terminal side goes all the way around, it's traveled 360 degrees.
Or 720 radians.
No.
No. Is it not 720?
No, it's not. What if I only go half a circle?
180.
Is he the only one that knows that?
Yes.
Didn't you have that in geometry?
I did something else.
What about just up to here?
That That would be 90 degrees.
Yeah.
How much?
90 degrees.
Oh, you got that one. How about all the way down to this axis?
270.
Oh, okay. You guys are pretty smart. The most common unit of measure for the angle is the degree. A degree is equivalent to something of a full rotation. 1 degree is how much of the rotation?
1/360?
Louder.
1/360?
Where'd you get the 360 from?
Because there's 360 degrees.
There's 360 of them in the circle, so if you just do one of those, which would be almost impossible to graph it by hand, to ask you, okay guys, I want you to graph 1 degree. Here I go. Looks like this. Here's the initial side. Here it is. I even think that's wrong. That's probably too big. It didn't open up hard. It doesn't hardly open up at all. Okay. So let's do some pictures and see how they look. Oh wait, you guys all cheated. No wonder. Look at all those answers over here. You guys were cheating. Admit it. You was? You did. That's not cheating then, was it? It was right there in front of you.
The answer's right here.
So where would? Oh, I gotta name something else. The author does not do. Guys, when you look at these 4 squares that are here, these are called quadrants.
Oh, they're numbered weird.
This one is quadrant 1.
1.
You go this way, which is counterclockwise. This is quadrant 2.
And then 3 is on the
And if you
bottom.
keep going, you'll get to quadrant 3. Go all the way around, that gives you're in quadrant 4. So when I do 65 degrees, you told me that if I go all the way, that would be 90 degrees, right?
Yep.
Anybody else?
That is 90 degrees, sir.
I looked out and nobody was even looking.
I was doing stuff right now.
So 65 has to be less than that. And we just want to be, is it half or more than half?
More than half.
So is this close enough for government work?
Yeah, sure. I can't even.
That angle here?
Yeah, it's pretty enough.
All right. And 320 is bigger than what? Is it bigger than 90? Is it bigger than 80? Is it bigger than 270?
Bigger than 270.
Is it almost 360?
No.
By 40 degrees.
It's 40 degrees away, right?
Quadrant 4.
So it's going to be in quadrant 4. So here goes. Probably stopping around here. Would you take that angle? Now, which angle is it? Is it the one inside here? Is it this angle? Or is it the angle on the outside?
On the outside?
It's the angle on the outside. All the way to
It should be
here
less than half too.
takes to 320 degrees.
Yeah.
This one I don't like.
What are you doing?
So I'm just throwing this little paper out.
Glad you found a use for this class. Good garbage cans. Are you writing anything down?
No, yes, sir, I am.
Oh, okay. All right, then help me out with 415, Jabron. 415. Where would 415 go?
415?
Yeah.
Quarter of Y.
Quarter of the way to Y?
No, like 2 up and then to 3.
2 up and 3. We're rotating. If I moved my leg this far, I moved it 90 degrees.
If you look.
Not enough. If I move it, keep going. How much degrees is this one, Jabron?
I get what he's saying.
I get what he's saying. Yeah.
I get what
Okay.
he's saying.
180.
And if I go all the way here,
2 up, 3 to the left, 2, 3. Okay.
how much? If I go all the way around?
360.
Oh, I need more, don't I? How many more do I need? No, 1/2.
Less than 1/2. Because max.
It's just over half.
Yeah, just over half.
Half of what?
Half of the first quadrant.
Half of the first quadrant. Why? How many degrees do I need?
55.
Oh, perfect. Another 55. Is that what he was saying?
Yeah.
So, now that you put it on that perspective, that's perfect. It was bigger than a whole thing. So nice job, Gibran. 360 gave me, you said 55 degrees in the quadrant 1. Nice. Okay, I get it now.
Very cool.
I got to dig more information out so I can see what's going on. Okay, negative means I go which way?
Clockwise.
And if I go clockwise just here, that's negative 90. If I keep going, that'd be a negative 180. That's too much.
Slightly less, 40 degrees less than.
So do what? Right about here?
Yeah, I guess so.
Is that close enough for the government?
Yeah, good for government work.
All right, good enough. And I can actually write it here, negative 140 degrees. Negative 15.
Oh, just a little bit, you know.
What quadrant would negative 15 be in, guys?
Quadrant 4.
Quadrant 4.
What?
Yeah.
A negative.
Yeah, it has to go quadrant 4 down here a little bit. Not very far. Is that close enough for government?
Yeah.
It's like, you keep on going.
I mean, it's a good thing we're not being graded on being perfect, because I don't have to get out my protractor and compass and, really spend 5 hours to do this. Negative 210.
Is
it-
second quadrant?
It's in the second quadrant? How do you know?
Because it makes like a, I forgot.
Because this is 180, and I need how many more?
30.
30.
I just think of it as like the image regularly with a negative and I just flip it upside down.
You're absolutely right. Okay, good job, guys.
That's a nice way.
It is. Now we're going to talk about radians, which this might be the very first time that you've done radians. In calculus, I tell all the kids, turn off that degree mode and put it in radian mode from here on in. I still cheat, and I talk like radians is a different language. So I'll ask the students, what is that angle in English? Because we understand degrees very good.
Very easily.
Radian's a little harder. Now, bless you.
Let's see.
A radian, bless you again. A radian is a unit of angle measure based on arc length. One rotation is defined as the measure of the angle formed when the radius is equivalent to the arc length of the intercepted arc. Aren't you so glad I read that?
Wow, that was very helpful.
Very helpful, right? We haven't had arc length. We haven't talked about intercepted arcs. Let me just help you out. 360 degrees by definition is considered to be 2 pi. And I'm going to put in a parenthesis the word radians, but I'm going to be honest with you. Degrees has a degree symbol, or the word. Radians have no unit at all. You can just say 2 pi is the full circle.
Oh.
So I'm over here. If I go around the full circle, that was 2 pi. Well, what if I do half a circle?
Then that would be 1 pi.
Just pi.
Just pi. Pi. What if I do 1/4 of the circle? That would be 90 degrees. What would you say that was?
0.5 pi.
Yeah, half a pi.
Wait,
I like that better.
half a pi?
I like to say, yeah, because what is half a pi?
Well, yeah.
It's delicious, right?
Wait.
Pi over 2.
What's your favorite pie, sir?
Blueberry.
I like good old like apple.
I'm tired of apple.
I like pecan pie, sir.
Oh yeah. Pecans.
Pecan pie is good once a year. It's kind of sweet for me,
I
though.
like
But.
peach.
Now, let's talk about converting, because when we talk about 2 pi and pi over 2, it kind of doesn't mean so much to the average person.
You like key lime?
So sometimes, key lime, yeah, I like key lime. I'm going to talk about a ratio. When you see 180 degrees over pi, they both mean the same thing.
1.
That means a 1, exactly. Because 180 degrees is pi radians. But if you don't like it looking like that, you can look at it like that. Pi over 180 degrees is also what?
1.
1.
Doesn't matter. 1 over
Doesn't matter. Now the question is, which one will I use? And it depends on what you're converting. If I'm converting radians to degrees, I want to have my degrees. Is that what he's doing? Radian equals, oh no, it's just a formula. Radians equals to, you take the number of degrees times pi radians over 180. Let me show you why. If I start out with, I want to know what radians are. If I have, we know what 90 degrees is, right?
Yep.
We already know the answer. We wrote it up there, right? Pi over 2.
However, it's
But let's pretend you don't know, okay? I want to convert that to radians, so I got to multiply it by a fraction, either the first one or the second one. And since I want radians, I want the degrees to cancel out.
wouldn't it make sense for the degrees to be on the numerator?
No,
No?
you want the degrees to be in the denominator.
Oh, okay.
That's how they cancel out.
Oh.
So on top, I'm left with pi. And so that's just 90. You can call it 90 over 1 if you want. Do you see what I'm saying about the degrees canceling out? Hello?
Yep.
The degrees cancels out, which is good because I want radians equals to pi over, well, I forgot my 90. 90 pi over 180. Well, there's the answer, but can you reduce it and make it better?
1/2 or
One
not
half
really.
pi.
Pi over 2, right?
Yeah.
Which is the same answer that we already agreed on, right?
Yep.
So that's the formula you have if you want radians. Notice here, degrees is on top, degrees is on the bottom, except they don't do a good job at writing the symbol. I think if you write the symbol, you'll understand this is degrees as well as this is degrees.
Oh, I get it.
That's why.
That's how it works.
Yeah. So now, if I have degrees, if I want degrees, all I have is radians. For instance, I'm going to make this up for you. I'm going to go 3 pi over 2. And since there's no symbol, it's radians. But I want to convert that to degrees. So what I need to do is put the degrees
180 over.
at the top. This time the degrees has to be at the top in order to get the degrees at the top. 180 over what?
Pi.
Pi. What cancels?
Pi.
You got lucky in this case. The pi's cancel. So I'm left with 3 times 180 over 2 degrees. So what is 3 times 180 over 2?
Divided by 2 is 270.
270 degrees. Well, you know how I made this up in my head? Watch my math. Watch this. You're gonna be so amazed. If this is 0 radians, and this is pi over 2 radians, right? We already agreed?
Yeah.
If I double it, pi over 2 times 2, pi over 2 times 2, it's pi. If I want to go another 90, wouldn't that be pi over 2 times 3? Times 1, times 2, times 3. And that's why we got the answer of this 270 degrees, which you told me that earlier, must be, where's my problem at? 3 pi over 2. 3 pi over 2. Okay, so now we got to practice it. Did. So I guess I'll talk to you guys later.
Sir, just to point something out, that's why the stupid clock looks like that.
That is exactly why that stupid clock looks like that. You thought it was broke. Well, it is broke. The time don't work no more. But that I didn't want to throw it away because it's the unit circle. So here goes. You just figured that out.
Yeah, I was like, do I put this in the calculator and try to figure it out?
Now, the bad thing is now you just told everybody how to cheat. All right. So let's take 60 degrees and turn it into radians. So I want to get the degrees to cancel. So where does 180 degrees go?
The bottom.
180 degrees goes down here. What goes on top?
Over 1 pi.
A pi goes on top. So if you do the math, that gives you 60 pi over 180, and the degrees are already canceled.
Over 180.
What does that give you?
3, no,
Or
1 over 3
pi over 3.
Okay, I need to memorize this.
Or pi over
That 60 degrees is pi over 3. Just like I want you to memorize 90 degrees is pi over 2, okay? Let's do 16. 160. This is not special, so I don't care if you memorize
What if
this.
you just
Over
plug in
one
the,
pi
what if you just plug in
over
the number to next to pi and then over 180?
160 pi.
Right?
Make it really fast.
But you got to know, is it pi over 180 or is it going to be 180 over pi?
Well, yeah, you would know because in the second one it's just
So I'm asking you, what will I multiply? Pi over 180 or 180 over pi?
pi over 180.
But that would be true, pi over 180, because both of those has degrees, right? And I want the degrees to cancel, right?
Yep.
So what am I left with?
160 pi over
160 pi over 180.
I'm just saying it would be easy to just like plug the
8
160
over 9 pi.
there into the.
How much?
8 pi over 9. There you go.
8 pi over 9. That's one I've never memorized, and I don't think I'm going to memorize it today either.
Can we just leave it at 160 over 180? Or like 160 pi over 180?
You know what I like you to do. Reduce.
Mr. Cartwright,
Yes.
are like some of these part of the unit circle?
This is the unit circle.
Knew it.
Yes. Why are you asking that? Where have you seen the unit circle?
Because our friends goes to MSA and did pre-cal, and she started with the unit circle right off the bat. And like, I also did more math during the.
Yeah, we're a little behind.
And I also did more math during the summer with practicing trigonometry.
Oh, yay. So you are going to be the one we go to for help.
I saw the unit circle a lot still.
Then you, and that, did it just click right now?
No, because as soon as you said the pi over 2, I was like, isn't that part of the unit?
Where have I seen that before, right?
And I was like, that's a unit circle.
So they were making memes on it on TikTok about the stupid unit circle. I don't know.
Unit circle.
Oh my gosh, I guess that's a good reason for me to join.
No.
TikTok?
No, probably not.
I saw this. I was like, I don't want to do this.
Let's all dance the unit circle, right?
Wait, no.
Okay. Let's do 330 degrees. To turn that into radians, I multiply this by
Pi.
over.
180.
And remember, I wanted the degrees to cancel because we're turning it into radians. So that does cancel those 2 degrees. I'm now left with 330 pi over 180. And don't do what Adam said. Just leave it. No.
Nah.
Try to, I mean, you can reduce the zeros real easy. I'm only left with 33 over 18, and both of those divide by 3.
11 over 6 pi.
11 over 6 pi, or 11 pi over 6, same thing.
11 pi over 6.
All right. Okay, 45 degrees. We haven't talked about
Negative.
45, but it's negative. But you know what I want us to do? Let's do 45 degrees first, without the negative.
It's pi over.
So that would be multiplied by what? Pi over
180.
180 degrees. So the numbers cancel, leaving me 45 pi over 180.
Which cancels out to 4 or 1 pi or pi over 4.
Pi over 4. Memorize that one, please. That 45 degrees is pi over 4. And I'll show you the easy way about it. You got your unit circle. And here is your pi over 2. Well, if you cut that in half,
That's pi over 4. Half of
half of 90 is what?
45.
45. So this 45 degrees is also known as pi over 4. So what's negative 45 degrees then?
Negative.
Negative
Four.
pi over
Yeah, negative
4.
pi over negative.
Should be.
4.
Let's do to negative 230 degrees. You still cleaning? Wow. Well, you know, I got to give him a lot of credit because He could have done what others have done and cleaned out their backpack and left it all under the desk.
Oh God, no.
I clean out my backpack and just like try to get upside down and just go make it.
Yeah. So take negative 230 and multiply it by pi over 180 degrees to get the degrees. He's still going.
Negative 230 pi over 180.
You should move your backpack next to it so it's easier, you know?
What are you doing?
I asked them to unplug it already, because I don't want to.
Well, yeah, but then leave it there then.
Yeah.
Because we got time.
Can I go to the restroom when you have to take us back?
Yeah. Negative 230 pi divided by 180 reduces to what?
I've been thinking about that actually.
Well,
Is 23 a pi?
I don't know, but I know the zeros cancel.
Yeah, I know. I've been trying to find a number that goes into 18 and 23.
Maybe there is no other number.
Maybe 23 is a
23 is prime. Negative 23 pi over 18. Nobody said it was always going to be pretty. That's for sure. All right. Negative 75 times pi over 180 degrees. The degrees cancels.
75.
Negative 75 pi over 180.
Divide by 5.
Divide both by 5 is a good idea. If he divides both by 5, that's negative 25 pi
Wait, 25.
over 32.
75 divided by 5 is 15.
Yeah, that's what I said.
You put 25.
Okay. I lied then. You caught me red-handed. Gibran, what's 18 divided by 3?
Wait, 18?
18 divided by 3 is not 23.
Wait, 15? What?
I just want to know what 18 divided by 3 was.
Oh.
Trying to wake him up again. He's going to sleep.
Oh, he had it.
6?
It is 6, but I don't need that.
Oh.
No.
I was actually dividing by 5. So what's 18 divided by 5?
Wait, what? Wait, where's the 8?
10 divided 18.
15.
You won't get a whole number though.
What?
3.6, sir.
What's 3.6?
18 divided by
Oh, maybe it is. How'd you get it?
5.
In your head. You're right. What were we dividing by to reduce?
I'm just gonna go pee.
We were trying to divide by 5, weren't we?
We divided 75 by 5.
Which we got a
by 180 by 5.
So what's 180 divided by 5?
36
I was almost there. 36. I think they can reduce again.
by 3.
Negative 5 pi over.
Whoa.
That's not pretty either.
Yikes.
All right. Let's now go from, let's convert angles to degrees. The other way around.
So 180 over pi.
So now I got to do, my 180 degrees has to be on top. Oh, before I go on, I need to do one more angle that he didn't do. 30 degrees. We didn't do 30. 30 is important.
Oh, 30 is important.
Yes, because we did a 60, we did a 90, we did a 45. 30 is important because of a triangle, 30, 60, 90.
Wild guess, is it 1/3 pi?
I don't know, let's try it.
Because 90.
180, no, I'm sorry, pi over
Oh, 1/3. Never mind.
180 degrees. What does that give you? Somebody.
30 pi over 180.
Okay, I was hoping you could do the whole answer.
That's true.
Is
1/6.
everybody else is going to sleep?
Yeah, because I realized 90 wasn't the whole pi. 180 is the whole pi.
What I could do is get another quiz grade today by just shutting this down and giving you 2 problems before you leave the room.
That wouldn't be nice.
All right, moving on here.
Why would you give us a quiz on that if I don't understand what I'm doing?
Oh, if you don't understand what you're doing, I need to hear a question. We just did 6 problems where we did the same work for all 6.
I'm still confused.
So, confused with what?
When you get to, I don't know, after you, like, for example, number 8, after you write the 165 over 180.
Yes.
I don't know what you do after that.
We reduced the fraction.
Oh,
Simplify.
Either cut them both in half, divide both by 3, divide both by 5, divide both by 10. You know how to reduce fractions. And this is what I tell people who can never seem to divide is guess what? You type that fraction in your calculator, the 160 over 180, and hit enter. It might actually reduce it for you. But I don't know how the Inspire does it. I know what I have to do if I use my calculator. I don't bite that hard. Sometimes I do, but. All right, back to converting to radians. So I need the 180 degrees on top to get the degrees in the answer over pi. Notice what cancels? The pi's did. It's like a Christmas miracle. 5 times 180 degrees over 18. It's just a multiply and divide problem. I don't care if you reduce it in your head, but I do think 180 divided by 18 is a 10, I think.
It's 50.
How much?
50.
Oh, I didn't hear it again.
50.
The answer is 50
Yeah.
degrees, right?
That's
Thank
50
you.
degrees.
Now, how about 11 pi over 9? Again, multiply it by 180 degrees on top to make sure that's a degree answer over pi. And again, we're so lucky that the pi is canceled. And if I want to do some of it in my head, 9 goes into 880 20 times.
So it's going to be
320 what?
220.
220 what? Degrees. Okay, let's do another one. And I got a trick for this one, but I'm going to do it the other way first. Multiply by 180 degrees over what? Pi. Thank goodness. The pi's cancel out.
Bye-bye.
The 3 cancels out with the 180 by 60. So
Actually work.
420
420 what?
degrees.
But I got another trick for you guys that are good at mental math. What if you remembered that pi over 3 stood for what? I did it over here somewhere.
Oh, 60 degrees.
It is 60 degrees. We did that a minute ago, right? So what if, where am I at? I got lost. Here goes. If we know this is 60, then the answer is 7 times 60. Isn't that cool?
No, wait. Oh, okay, that does make sense. Never mind. I'm
Oh, okay.
overthinking.
Don't overthink. You're going to pop a brain vessel. Guess what? Pi over 6, you should have it memorized, is what?
That was the one. That was the mistake.
And I'm going to remind you, pi is this whole thing, right?
Negative 30 degrees.
Yes. That's pi?
Yeah.
I know we want the negative, but that's okay. So if I divide this by 6, that means I need to have 3 parts here and 3 equal parts here. And so each part has to be how many degrees?
30 degrees.
And we already had that, right? Pi over 6 was 30. Well, pi over 6 is 30. So that really is a negative what?
Negative 30 degrees.
That would be a negative pi over 6. That means it went down this way, one of those pieces. There it is. See? This one, I don't think I have a clue. I have no shortcut for you. Sorry.
Especially when there's a prime number on the...
Prime numbers, I hate prime numbers. So that's going to give me, why am I putting the 180 on top?
So the pies can cancel out?
Oh, so the pi's can cancel out. Now, I got to give you a disclaimer. Not every radian problem is written with pi in it,
Oh no.
but these all are. So that turns into a negative 19 times 180 degrees over 12, whatever that is. Somebody real quick.
Wait, negative 285.
Negative 285.
Negative 285 degrees exactly?
Yes.
Okay, is there a shortcut for 18? Do we remember what pi over 4 is?
Oh, wait, pi over 4 is 45?
It is, because if you take all the way to pi, divide that up into 4, here they are, 1, 2, 3, 4. Half of this distance must be 45 degrees. There you go. So 45 times a negative 3 is
Negative 135.
Yeah,
135 What's the unit?
Degrees.
Degrees, okay. I was saying about you don't always have to have, I could ask you this. I want to convert 17.356 radians to degrees.
Wait, sir, can I see how you solved the first two? I just want
What first one?
on the second part because I was interested.
First one and the second part.
Second. Yeah, the radians to degrees.
That's this one right here, 13.
Oh, yeah.
So in the future, I could give you a decimal radians. See, that's radians. How would you do that one? I want 117.356. Convert that to degrees. What would I multiply by?
I don't know, please.
I need the 180 degrees on top, and the pi goes on the bottom. But don't be afraid. The pi's can't cancel because there's no pi up there. This is in decimals. You still have to do the multiplying and then divide by pi. So I'm just giving you heads up. Now, the last terminology is coterminal. Oh, no, we got something else. Yeah, coterminal. Coterminal means that two angles share the terminal side. They may be different. For instance, if I have an angle at 60 degrees, I guarantee you that if I go to 60 and then decide to go all the way around again, that's another angle. That second angle, I started out with 60, but then I took 60 and I added 360 to it. 60, how much is it?
420.
That would be coterminal. Get this, watch this. If I choose to go the other way instead, negative, what would that angle be? That would be a negative 3 what? Wouldn't it be 300? Because all the way around would have been a negative 360, but I added the 60 to it. So I could take a negative 360, go all the way negative direction, and then add the 60 to get rid of it. And so I get the same negative 300. All three of these answers are called coterminal. And if you have nothing else to do on a Friday night, and you have a 70-degree angle, you're going to love this, guys. And you want a whole bunch of coterminals. Watch this. 70 plus 360. Here's my 70. Then I got 70 plus 360. Or I can do 70 plus 360 plus 360. What am I doing each time? 70 plus 3 times 360. 70 plus 4 times 360. Those are all going to be coterminal angles. Isn't that fun?
Perhaps.
You could do this all night long and never get tired, right? So I want to know if these two are coterminal.
I was going to say they are, but I don't think so.
Well, what I did for the other class, I said, let's look at the picture. 305 goes all the way around till I get to here, and I realized that 305 would leave 55 degrees to get to 360. Is that right?
Yeah.
The other angle is a negative 55. Bingo, negative 55. Are they coterminal?
Yeah, I just thought of like 360 minus 55. Is it equal to 305? Then yes, then you're concerned.
Oh, that's a good idea. Huh?
What is the number set?
This was 55. As I went negative 55 to go down, and it's positive 55 to go back up. I like your trick, Adam.
That
Will,
only works with numbers, though.
will it work with 20?
Yes.
How?
It's not because actually, it's 360 minus 170 isn't 30.
360 minus 170 is not 30. So you're saying no, right? And watch this, guys. Here's 30 way over here, quadrant 1. 170 negative means almost over here, right?
Yep.
Can this way be coterminal with this? They don't end in the same place. So that answer is no. Okay, let's try one. Whoops. Let's try one with radians to see if these are coterminal. Pi over 4, we did that math earlier, found out that pi over 4 would be if you had all of pi and you divide it up into 4 pieces, you'd have that piece, that piece, that piece, that piece. And since this is 180 degrees, and you divide 180 degrees by 4, that gives you a pi over 4 right here is really a 45-degree angle in English. Now, when I say negative 9 pi over 4, that implies the negative direction, clockwise. And I'm going to start from my initial side and go, here's 1 pi over 4, here's 2 pi over 4, here's 3 pi over 4, here's 4 pi over 4. Interesting. 4 pi over 4 is pi. Now, of course, these are all negative because I'm going clockwise. So there's 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, wait for it, 9 pi over 4. Because this little bugger went all the way around until it got to here. So the question is pi over 4, the angle that goes out like that, and here's my terminal side right here, is that the same as the negative pi over 4 that ended up going backwards all the way around until it came out to here? Is that coterminal with this one? The answer is no. The terminal sides are not in the same place. Let's try another radians. Okay, our buddy pi over 2. We've learned that pi over 2 means if this whole thing is pi and you cut it in half, then we are here. That's our 90-degree angle. In English, 90 degrees. But I need 3 of those 90 degrees. 3 of those 90 would be here's 1, here's 2, here's 3. 3 times 90 degrees is 270 degrees. The angle actually is out here because it went all the way out. This angle opened up all the way out to here. Negative 5 pi over 2 looks like this. Here's negative 1 pi over 2. Here's negative 2 pi over 2. Here's negative 3 pi over 2. Here's negative 4 pi over 2. I've done a whole circle. 1 more pi over 2. There it is. So what this thing did in the negative direction, it went all the way around and a little bit more. So it actually terminates here. Sure looks like they terminate the same, don't they? The answer is yes, they're coterminal. The remaining problems want us to find 2 coterminal angles, and it'd be so easy if they didn't give me any rules. Like right now there's rules. They want a positive one and a negative one. If they didn't give me any rules, it's really simple. If I have a 150-degree angle, that's less than 180, so it has to be out here. There's one angle. To get a coterminal, all I need to do is go to the same direction and go all the way around until I get back to it. In other words, I go 150 and then I do a whole circle. So 150 degrees plus 360 degrees is definitely a positive coterminal angle. I'll add that up in a minute. If I want another coterminal, and I'm out here, I could go around the circle again. So that would have been the 150 degrees plus the 360 degrees plus another 360 degrees. We'll do that math in a second. How about a third one? You get the pattern? 150 degrees plus, instead of 1, 2, 3 360 degrees. Now that's easy. 3 coterminal angles. And if I add, I'm going to do one of them at least. 3, 4, 510 degrees would be coterminal to the 150. This one would be 100, 300, 600, 700, 750, 750, 850, 870, I think. And for this third one, I'll let you do it. But the question was, we were required to do one positive and one negative. And there might be a shortcut. I think Adam had a shortcut. Anybody who knows Adam. So how does that look as a picture? I have, wrong one. Start with my 150 degree angle, because that's where I need to know where it terminates. Well, it terminates out here. There it is. There's my 150 degree angle. So I need another angle, but he wants a negative value. So if this is my initial side, why is it not writing? Weird. There it is. I need to go this way to end up here at the terminal side. So the question is, well, how big is that? So you know it's negative 180 plus a little more. Well, how much is that little more? If this original was 150, then this must be 30 degrees in order to get the total 180. So one way of doing it is take your 150 degrees and then go from there. I need to go, let's see what I want to say. If I do the negative, that's 180 degrees minus 180 degrees. No, not 180. It's 180 plus 30. I'm sorry, 180 plus 210. 150 is where I was. And so I need to go to the negative direction to get to the same place. And that'd be a negative 200. Why am I'm not subtracting? It is just a negative 210 degree angle. Now, look at it this way. If you take the 360 in a full circle and just take away that 150 degrees, then I think we get 210. But that was 360 going left, 150, so that would be my negative 210. So there's a mathematics to do it. I did it with a picture and I did it with mathematics. So you can see that it might work. 265 degrees, well, it's really easy. It's really easy. I'll do the picture here. 265 has to be less than 270. And we've learned that 270 goes all the way to here. But I need to do less than that. So I need to go 5 degrees less. So there it is. There's my 265 degrees in a positive direction. Positive 265 degrees. And so if I want a positive angle that's coterminal, I start at that 265 and I go one time around or two times around or three times around. I'm lazy. I'm just going to go one more time around. So that became 265 degrees plus 360 degrees. 3, 4, 5, 625, I think. You can tell me if I'm wrong. There's my positive coterminal. Now to do the negative angle that's coterminal, it's simply this angle that is going from the initial side, negative angle, will also be an answer. So I know it's negative 90 plus 5 degrees because this was 5 degrees less than the 270. So 90 plus 5 was 95. I believe my answer would be a negative 95 degrees. Let's do that magic trick and see if it worked if I do 360 degrees. And it's actually, I'll show you what I mean in a minute. And I subtract the 265. Let's see. I don't know how to do that without a calculator, so my brain's not working. 360 minus 265. Well, I think it's, if I subtract correctly, there's no guarantee. Subtract that. Okay, I was seeing something. I do it an old style of subtraction. I make that. Oh, I keep getting the wrong pen. Make that a 10, and I put the other. Keeps giving me the wrong. Okay, there it is. Make that a 10. Put them in. That's a 5, and then 6 minus 7. I need to borrow 1 again. 16 minus 7 is a 9. 3 minus, that's a 95 degrees. It works. That works as well. You could look at it more like this. You could say go 265 degrees minus the 360. That way you know that it's going to be a negative answer. Same thing with over here. I could have done the 150 minus the 360, and we'll still get the negative 260. It's just however you want to look at it. However it sees it. Now, okay. We're starting out with a negative 25 degrees, so you do know that's about down here. Negative 25. There's my negative answer already. So I need to get one that's positive and one that's negative. So my advice to you would be, let's do that negative angle, negative 25. And let's see, I'm down here. From there, just go ahead and go all the way around the circle. So that'd give you a negative 25 degrees. And I'm adding 360. And you know, since you're adding 360, it's bigger than the negative, so it's going to give you a positive answer. That's going to be 335, I think. 335 degrees. Now, without doing any fancy pictures. Well, if I start with the negative 25, why don't I just, if I'm already down at negative 25, why don't I just keep going around a whole full circle negative? Minus 360 degrees. And that'll also be a negative answer. That'll be a negative, that was 360, negative 385. So now I've got a positive coterminal and a negative coterminal, both coterminal with a negative 25, assuming I did everything right. How about in radians? Now I'd love to tell you what pi over 12 is in English, but all I can really tell you that it's, I don't know if anybody really cares, it's 1/2 of a pi over 6, because 6 times 2 is 12. So 1/2 of pi over 6 we learned was a 30-degree angle. Half of a 30-degree angle, in case you want to know, is 15 degrees. Why do I spend time looking at it in degrees? Because I don't understand pi over 12. I understand 15 degrees. 15 degrees goes up a little bit this way. There it is, 15 degrees. But we really shouldn't be calling it 15 degrees because we're in radians. But in English, it looks to me like that, 15 degrees. But that's really pi over 12. So what do I do if I want a positive coterminal? I take my pi over 12 and I go, here's pi over 12, and I go all the way around. Now I'm going to try to trick you. Would I add 360 degrees? I don't hear you. you should be saying no because we're in radians. I should be adding 2 pi. And I'm pretty sure the author is going to make us simplify that. This is the exact answer. There's nothing wrong with that answer, but it's not simplified. So because we're still practicing math, I'm going to do my 2 fractions being added together. I start on the bottom left. I multiply straight up. 1 times pi is pi. Plus, go to the bottom left. That's at 12. 12 times 2 pi is 24 pi. 24 pi. All over. I multiply the 2 denominators. 12 times 1 is 12. So that answer simplifies to 13 pi over 12. Well, who would have thunk that? Okay. Now, that's my positive coterminal. So I'm going to try to keep it easy. If I go, I'm at a 15-degree angle. To get a negative angle, I would have to go in the negative direction all the way around, and that'll give me a negative answer. So I was at pi over 12, and I'm taking away a whole circle from there, which I'm taking away 2 pi. And I'm going to do the same mathematics. That gives me 1 times pi minus 24 pi all over 12. That's a negative 23 pi over 12. Notice it's negative. Notice it's positive. Coterminal with pi over 12. Are there other answers? There's always other answers, but I'm trying to keep it simple. One's to the right and one's to the left, and maybe I can get it. 7 pi over 6. Let me see here. 7 pi over 6. Remember, pi over 6 was like a 30-degree angle right here, 30. And then there's a 60, and there's a 90. So there's 3 of them in the 90 degrees. And if I go 3 more, there's my pi divided by 6. My point is this. I need 7 of them. So this is 1, 2, 3, 4, 5, 6. 6 pi over 6 would be a pi. Duh. Of course it's a pi. But I need to go 1 more. There it is. What is it in English? 180 plus 30. 180 plus 30 is 210 degrees. Nonetheless, if I'm at 7 pi over 6 sitting here, to be coterminal, I will take my 7 pi over 6 and I will just go 2 pi around, making another angle there. Do the magic fractions. 1 times 7 is 7 pi. 6 times 2 is 12 plus 12 pi, all divided by 6. Add that up, 19 pi over 6. Do another one. Oh, I didn't do the negative angle. If I'm already at 7 pi over 6, I may as well take away 2 pi to go the other way around. So I was already at 7 pi, but I'm going to go from there, start there, and go all the way around negative. So that's what that is. That gives me 7 pi minus 12 pi all over 6. Sure enough, it's negative. It's a negative 5 pi over 6. One more. It's already starting out with negative. Negative 11 pi over 18. Let's see. Let's see, how can I do it? Pi over... pi. Well, I can do a pi over 3 and multiply the bottom by a 6 and the top by an 11. So the negative, it's really it's going to be a 2/3 of pi over 3. I don't know if that's too much work. The problem is I'm trying to make sure how big it is. So you can go and run with that, what I just did. You can say it reduces to a no, it's not 2/3. It was 11, not a 4. It's 11 sixes of a 30-degree angle. It's 11 sixes of a 30-degree angle. It's not very pretty. 11 sixes times 30 is actually a negative 55 degrees. So in English, that's a negative 55, I think. If I'm wrong, yell at me, and I'll give you some points. But I'd have to go to my calculator and actually do the math. Well, we don't have to. We could actually just... What did we learn earlier? 11 pi over 18 times, that's going to be in radians. I want to turn it to degrees, so I'm going to multiply it by 180 degrees over pi. Let's see if I'm right. Boom, boom. 18 goes into 180 10 times, and it doesn't look like I'm right. Well, negative 11 times 10 is a negative 110 degrees. Uh-oh, I lost something. I said a 55 negative. 11, 6 times 3 is 18. Pi over, oh, I'm sorry. Pi over 3 is not a 30-degree angle. What planet am I from? Pi over 3 is a 60-degree angle. Another 60. Wow, that was a brain burp. It should be times a 60. 6 goes into 60, 10. There it is. There it is. 6 negative 110. Okay, I got it. It's a negative 110 angle, which tells me that I'm going this way. 90 plus another 10 degrees. So there's my negative 11. I'm glad I checked the work before somebody yelled at me on YouTube. There's that angle there. So if I want a positive coterminal, I'm going to take my 11 pi over 18, and I'll just add 2 pi to it. That would mean I went this way, and now I'm going to go all the way around this way to be terminal the same place. Let's do the magic math. There's a magic 1 under here. That's a 2 pi. 1 times negative 11 is negative 11 pi. Plus 18 times 2 is a 36 pi all over the 18. 36 minus 11 is 25 pi over 18 negative. Oh, that's positive. I was trying to get positive. To get the negative one, I was sitting at negative 11 pi over 18. I will go the other way around. In other words, I went negative 11 pi over 18. I will keep going negative one more whole circle. That meant negative 11 pi over 18 minus 2 pi over the 1. That gives me, again, negative 11 pi, but this time it's minus 36 pi over the 18. Now they're both negative, so it stays negative. Negative 47 pi all over 18. I don't think it reduces. Okay. Well, there the whole thing is. Okay. Hope you had fun. Learned a little bit of magic fractions, and I enjoyed it. And as I said in class, and then the regular one work right now, because it goes on to another lesson. So I'll be creating the video for this lesson in next week. You guys will finish this lesson. And once you finish this, these minutes and seconds in, where we talk about, you will have the homework. You'll have this for both of those angle. Well, all right. We're going to talk about arc length and areas of sectors. Let me fill you in what an arc length is. Let's assume we start out with this weird polynomial graph. Okay? Well, that may not be too polynomial. It's morphed. But what if I wanted to find the distance traveled, that if I started here at point A and I ended up here at point B? Wouldn't that be hard to calculate the exact distance?
Yeah.
because the distance formula doesn't apply unless it's straight. And you'd have to cut this up into like a million zillion pieces, find the distance of that, find the distance there, find the distance there, find the distance, then add them all up, right?
That wouldn't be nice.
Well, in calculus, that's what we actually do.
Ow.
We find in calculus BC, we actually cut that up into an infinite number of pieces and find the length of each of those pieces. So you have no way to do it right now. But anyway, that distance that we find is called arc length. Arc length. It's the distance on a curve. The symbol is S. Now, what if we use a curve that we know about? That's a curve that is a what? A circle. Let me ask you a question. What if you wanted to find the distance you traveled? Let's say there's a circle centered here, and this is 5 yards radius. What if you start traveling here at point A, and you keep on traveling, you keep on traveling, and you keep on traveling until you ended up back at point A? Well, that's 360 what? That's the angle traveled 360 degrees. We call that a central angle. Okay? But the distance is called what on a circle?
Circumference?
Oh yeah, so that would be the circumference of the circle. And we all know the formula for circumference of a circle is 2 pi r. Interesting thing. You see 2 pi in the equation?
360.
Where have we seen 2 pi?
2 pi?
Yeah.
In the 90s?
It, you know, I am recording you guys.
Well, that makes a lot more sense.
It's 360 degrees, right? It's in radians. So you're going to see something. But what that's easy to do, because I can easily say my circumference is 2 pi times my 5 yards, and find out that's 10 pi yards.
That literally works.
So your arc length is the circumference of the whole circle. But you know it's not going to be that easy. We're going to have a circle, and my angle will only be part. Theta will only be part. And so I want the distance from part A to point B. So it's going to be a part of a circle.
A arc.
The arc. But the problem is theta, we do the formula is with radians. You notice up here?
Yep.
Radians. Even for the circle, it was already radians. And you didn't even know you were dealing with radians when you were in 7th grade or 6th grade when you learned 2 pi r.
Everything that has to do with pi is automatically a radian.
There's a good hint that it might be. Here's your formula, the easiest formula in the world. Arc length S is equal to your radius times the angle. You get it? C is 2 pi r. I just have it reversed. There's my theta. There's my r. I like saying S is equal to rho. It sounds so cool. So r theta. But when we use this formula, it's understood that we're using radians. So number 1, not a problem. It is in radians already. So the sector looks like this. Now, by the way, I got a shortcut. 5 pi over 6. I know that pi over 6 is the same thing as 30 degrees. 30 degrees times 5 is 150 degrees. So it's a pretty big angle here.
May I use the restroom?
Hurry up. Did you? You did. Hurry up. Hurry up. Hurry up. We got people watching this video wondering, what am I doing now? All right, so this is going to be the inscribed angle, or central angle, is, I told you, is 150 degrees, didn't I? Yeah. Because 5 times 30, pi over 6 is 30. I told you to memorize that. So, but I can't use the 150 degrees, even though I would love to. So I got to go S is equal to r theta, which is r is 3. Theta in radians is 5 pi over 6. The exact answer is 15 pi over 6. Let me reduce it. Let's not be Adam. Let's reduce it. Divide both by 3, 5 pi over 2, and it's going to be in feet. And yes, if you don't put your units, you will lose some points. Now, that he wants us to give the answer in terms of pi. That means exact. But he also wants you to take a calculator and give me the answer rounded to the nearest tenth. So the exact answer, if somebody could be so kind as to multiply 3 times pi, take that divided by 2.
Oh, 1 moment. Oh, currently trying to figure out.
Oh, no, it's
It's around 5 something probably. Between 4 and 5 probably. 4.71.
4.71.
So I'm going to just keep it at 4.7 feet because he said nearest tenth. Piece of cake, isn't it?
Wait, how do we get the 4.7?
They use the calculator. 3 times pi divided by 2.
Wait, how did you get 3?
I reduced 15/6.
Okay, 6.
Oh, wait, did I divide wrong? It's 5.
15
I'm
divided
sorry.
by 5.
Sorry, Emma. It's a 5 times pi divided by 2.
That's the thing I was trying to figure out.
Oh, well, you know,
That makes sense.
my old age is getting the best of me. Now you know why I'm telling everybody that I'm going to call it quits.
Woo.
7, let me erase this.
7.8.
Let me hide the evidence that I made a mistake. Nobody will remember that I made a mistake. Say it again, Emma. 7.85, that'd be 7.9.
The next digit after 5 is 3. It doesn't round up. It rounds
No,
down.
what was the number? What'd you say to me? I didn't hear you right then.
It's 7.853.
Oh, 8.5. It's still going to be a 9.
Oh, never mind.
5 moves the 8 to a 9.
Do we just round it all to 8?
No,
To the 10th.
that's not rounded. He said rounded.
Oh, okay.
Oh, okay. So you want the answers in decimals, right?
What's that?
If they have
So you want the answer in decimals?
He wanted both answers.
Oh, so fraction is
Yeah, well, right. This is the exact answer right here. I love it. This is my approximation. That's why I should have put not equals, but approximation. Let's do another one. Pi over 4, I asked you to memorize that. Do you remember what that is?
Actually, I want to test the theory.
Is it?
45?
It's 45 degrees. That's your friendly neighborhood 45 degree. And so my radius is 14.5 inches. So I have to still use the radians anyway. The only reason why I drew it as 45 degrees so that you would see how big it could be.
It makes sense.
Okay, because who knows what pi over 4 looks like? We don't. We're all kind of like crazy. Yes, if I think about it and I remember that it's 45 degrees, then I have an idea. So S is equal to rho, R-O, not in the Greek symbol rho. And that would be 14.5 times the angle. I got to keep it in pi over 4. And unfortunately, I can't even do any of this in my head because it's 14. If you want to look at it, it's 14.5 divided by 4 times pi. That would also be legal. And that would also be inches. That's a perfectly good answer. If you put it in your calculator and hit enter, it'll reduce it for you. But I'm okay with that number. I don't even care if it reduces to 7.25 over 2, which it also could be 3 point something. Who cares?
I don't think it's... Wait, what?
Well, I could reduce and keep reducing, but approximately, if I did the math right, do you agree with that fraction?
Yep.
Okay, could someone key it in the calculator and multiply?
11.388.
11.388, that'd be 11.4 if we're following the directions. I think it's okay if arc length is to the nearest tenth. It's not a big deal. We're talking about a tenth of a inch really isn't very much. So to go to 100th of an inch, let's do another one. 3 pi over 2 from experience, that means 270 degrees. How do I know? Pi over 2 meant 90. Times 3. So really I'm looking at a super huge angle here. that the circle goes around a lot. It's almost around the whole circle. There's my, it actually looks like that. And this is part of the circle that I'm not using right here. So I'm finding that black arc. So it doesn't really matter how big it is and how it looks there. S equals R theta. S equals 0.5 yards. That's big. That's half a yard. That's like 1.5 feet. Times 3 pi over 2. And if you really think about what 0.5 means,
Divide by 2.
that actually means 1/2, doesn't it? So I'm just showing off right now. You could actually call it 3 pi over 4.
So is it 3 pi over 270?
Yes, it is.
Could also be 1.5.
That's what I said. This is a 270-degree movement.
Okay.
But you don't use 270 in the equation. You have to use in radians. So I think it's 3 pi over 4 yards. But you had a question, Jonathan?
Could also be 1.5.
Yeah, it would be just as well to say 1.5 yards is fine. But what's the decimal, though?
Decimal would be.
Oh, not 1.5 yards. It's 1.5 pi yards.
I thought it was 1.5 or 2. 2.35. No, 2.34. I mean 2.4.
3/4 doesn't make it go to 4.
Wait, 3.5. 2.35.
Okay, 2.4 yards.
So what happened to the 2 as a denominator?
Right here, I multiplied it by this 2 and made it a 4.
Oh, that's a 4 yard.
Yeah, I made it a 4. All right, now, I'm not, just because I leave this one blank doesn't mean you shouldn't be doing them. You need all the practice. I don't give you a lot of homework. You should always try to fill in your notes. If you don't have it here, it might be in another video, but probably not since this is the video I'm posting. All right, this one, what's different about number 5?
It's in radius, or not radius.
In degrees. Oh, no. So I need in radians, but I'm going to kill, where's my pass?
Oh, other guys too.
I didn't make the rule. Anyway, moving on. So S is still R theta. And in this case, R is 8.4 meters. And here's what I'm going to do. I'm going to kill 2 birds with 1 stone. I know I'm looking at 15 degrees, but how can I cancel it out and turn that into radians? What could I multiply 15 degrees by?
Isn't it
Pi over 180.
pi over 185?
Exactly. It's pi over 180 degrees. And how did I know 180 went in the bottom? Because the degrees has to cancel out, right?
Yeah.
See that? Degrees cancel out. That's how I know it's pi over 180 and not 180 over pi. So now that I have that, the exact answer looks like 8.4 times 15 times pi
Over 180.
all over 180. Well, that's not very exciting, and that would be meters. Not very exciting at all, guys. So I think the estimate is probably nicer. But I had people the last class, they had trouble typing that in.
Can we just put 15 pi? 2.225.
Say it again.
Can we just put 15 pi instead of 15 times pi?
15 pi times 15.
No, 15 pi instead of 15 times pi.
Where are you getting? I'm not sure what you're saying.
Never mind.
Say it slower.
Like instead of putting
Whoops.
15 times pi, it's going to be 15 pi.
It is, yeah, same thing.
2.2.
But in your calculator, you're going to multiply it, don't you?
I don't know.
He wants to know if I don't have to use that parenthesis, is what he's saying.
Yeah.
Yeah, it's the same thing. 15 pi is the same thing as 15 times pi.
Yeah, so 2 pi.
Over 180.
Yeah, I'm just showing him that. So what do you get, Hema? 2.199? That'd be 2.2 meters. That was exciting. So this is supposed to be a lot harder because the problem was given in degrees. It wasn't that much harder, but it is for some people. All right, let's do another one. big degree, 330 degrees. Could I convert that into radians?
Yep.
I certainly can. I can call that, I think I can do it. Let me try it in my head. Well, I don't want to do it in my head. I think it's 7 pi over
It's not
3. No, 7 pi over 6, I think.
It is 6. It's 11 over 6.
11? Ah, so close.
It's close. You got it really,
7, 11.
really good.
Anyway, it's not worth doing in your head. Sometimes your head gets broke. So let's see. S is r theta, and r is 10.5 millimeters. Theta is 330 degrees, but
Over 180.
I need to say pi over 180. So I know what Jonathan just did. Jonathan just did this. It's kind of cool. 10.5 times the 330, and he said over 180. Then he's still going to have to go times pi. It's the same thing. And that'll be millimeters. That'd be the exact answer, no matter how you put it. Could you reduce that? The way Jonathan wrote it, definitely the zeros cancel. Definitely 3 goes into 3311, and 3 goes into 18.6. So,
Over 6.
yeah, you could do that, but you don't have to because you're still going to use a calculator, aren't you? So you don't have to be crazy like Jonathan and do the blue stuff.
Yeah.
Is approximately, no matter which way you slice it, 60.5 millimeters. You guys are doing pretty good. I'm hearing like at least 5 of you. It's not enough. I would love to hear 10 of you
I
talking.
think it's enough for extra points.
You think so?
What's with the extra points, man?
They like them.
Better to have it.
You want to do one more, or are you okay with this?
One more. I think we can wrap this up.
All right.
And then we can just like take a 20-minute break.
What?
One more.
S equals, we still have to do arcs, sectors. R theta, 1.8 times my 120 degrees, which is going to be multiplied by a pi over 180 degrees. And I'm so lazy that in my calculator, that's my exact answer. I'm going to say that's my exact answer. Could I clean that up a bit? Yeah, I could cancel out the zeros. I could reduce both by a 6 and go 2 over 3, make a 2/3 fraction. But why? I'm okay with that. I don't really want it to be pretty. Let's look at the estimation.
3.8.
3.8 feet. All right. And again, I'm leaving another one kind of naked here. Do I want to do this one? The central angle, 6 meters radius, has an intercepted arc of 10. Find the measure of theta in radians. Oh, this, look, if I write the formula, S equals R theta, they already gave me S. He says that the arc, the intercepted arc, when you take an angle and that's called an intercepted arc, okay? And this is called a central angle right here. That's the one that's connected to your center of the circle. Get it? Central angle, center of a circle. So he's already given me the S as 10 meters. So it's 10 meters equals to the radius, he says, was 6 meters times theta. I don't have the answer of theta.
Do we solve for 3?
Oh, then we just divide 6 on both.
Okay, so what do we get?
10 over 6 is equal to theta.
5 over 3 then
5
is
over
theta. Is that in degrees or radians?
Not radians.
Is it going to be like 5 pi over 3? Because of the pi thing.
Where'd the pi come from?
That's in degrees.
No, it's not.
Is it not?
You're saying that because you don't see a pi.
Not just.
And that's why Adam wants to add a pi. There is such a thing as 5/3 radians, and the pi is already embedded in there.
Okay.
If you want to know what it is with pi, somebody for fun, take 5 divided by 3, hit enter, and then go ahead and divide by the pi button.
Divide by pi.
Yeah,
What happens?
It's the decimal.
That's
I know. Give it to me.
0.50.
What if
0.530, and there's extras?
Yes.
530 pi. It's the same answer. I mean, so you don't have to see the pi. It's there, but you don't have to see it. I mean, to believe it. All right, enough of that problem. Let's go on. I hope that... there's 2 more applications. You should try to play with those. That's how, Mr. Doder, he'll put one of those on your test. Let's talk about what a sector is. When you have that central angle and the intercepted arc, what if this was a piece of pizza? And you wanted to find out, here's my pepperoni. La, da, 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 da. And you want to know how much the area of cheese that's on it. What is the area of cheese that's on my pizza?
So what's your favorite pizza topping?
Everything. Oh, except anchovies.
What?
I was about to say.
I don't want anchovies. So anyway, I want to find the area of cheese on my pizza.
No one puts cheese on the crust.
An area of a sector is equal to 1/2 r squared theta. Now, let's pretend it's a full circle, a full pizza, okay? And the radius is, what's the average radius of a pizza?
No idea.
Like 20 inches? No?
No,
That's a good sized pizza.
20 inches is diameter.
All right, 12.
Sure, let's do 12. It's quite
Or
long.
you said 20 is a diameter?
Diameter.
Let's make that 10 then.
That
So if I want to find out how much pizza, the area of that pizza is, normally if I say that theta is now 2 pi, true or false, whole circle?
it would make sense.
Yes? So area would be, well, let's just do the old formula. Pi r squared. Right? Isn't that true, pi r squared, if I just do geometry? So pi times 10 squared? 100 pi?
That would make sense.
Well, let's use S equals, not S, A equals to 1/2 r squared theta. Would that still be a 1/2 times a 10 squared? What's the theta in radians?
20.
We don't have.
It's a whole circle,
Oh, it's a whole circle. 2 pi.
2 pi. That's 1/2 times 100 times 2 pi. Notice what happens here. 1/2 of 2 cancels. What am I left with?
100 pi.
Wow, it's the same answer. Isn't that crazy? It's the same answer. Now, which was easier, geometry or trig? Oh, really? Then you guys are the smartest kids in the world. You thought this was easier than the...
like this more than geometry.
Oh my gosh, you're amazing. All
It
right,
explains a lot. I'm not gonna lie.
all right, don't lie. I don't want you lying.
And even the pi part, I used to just imagine 2 pi as something. Now I know what 2 pi means.
Now you know where it came from, right? Yeah. So area is 1/2 r squared theta. So here's a piece of pizza. 4 centimeters is the side of this angle here.
We want that slice.
So I want that slice. I want to know what area of pizza cheese do I have? So area will be 1/2 times, my r is 4 squared. My r is what? Uh-oh. What's the problem?
It's not in radians.
It's not in radians. So you're going to have to do what? 74 degrees times what? Pi over 180.
74 over 1.
Degrees cancel. A lot of magic happens, but I'm just going to write this out. What's 1/2 of 16? That turns into 8, doesn't it?
Yeah.
That helps my calculator a little bit. I still have my 74 times pi over 180. And the unit, it was in centimeters. Well, that's a very small pizza. Centimeter squared is my area. Now, could somebody please key that in and get my approximate answer? Oh, wait. key it in, but do not type in the pi. Just key in the 8. I'm going to shade it in here.
I see what you mean. So you can write pi right after.
Yeah, just key all this in. Whoa, why did I do that one? Wrong color.
You want the decimal series or fraction?
Fraction preferably.
I got 148.
You got 148
Yeah, 45.
over 45 pi centimeters squared. I sort of like that answer.
Very simple.
What does it say? Does he tell us? No, he didn't give us any directions. I like that answer. Go ahead and give me one decimal if you want to do it again, because I know some of you guys won't leave that fraction. 3.288. I'll make it approximately 3.3 pi. I'm still keeping pi in there.
It makes sense.
I mean, I'm still keeping pi. Now, if you don't want to, I know somebody in here, Adam, is insisting on typing in the pi. So what do you get if you type in the pi? 3.3 times pi. 10 something? 11? 10.36 centimeters squared. So look I just gave you 3 possible answers that are estimated. Here's the exact, just everything not even simplified. This is a good estimation. Here's a good estimation. Here's an estimation that a lot of people like. They understand 10.36. They don't understand 148 over 45 pi. I know my grandmother didn't. Bless her soul. I tried teaching her. And then she said, now you know how I felt when I was trying to teach you how to knit. I said, yes, Mama, I understand.
Did you ever learn?
No, she gave up on me. She said I was a worthless cause.
Okay. Ow.
I had a lot of knots. Oh, yeah. Area equals. She loved me. Then she tried teaching me cross stitch. Because when we lived with my grandma, we didn't have a TV. And so we were required to read books every day. We go to the library, get a book or two. Me and my brother would sit in the living room and we were reading in the evening. But then she would take a break and try to teach us to knit. And because she would make like 100 baby blankets every year and give them to the hospital.
Were you raised by a Victorian woman or something?
Well, I'm old, remember? So yes, I'm that old. My grandma was a Victorian woman.
They used to just drop me off at the library.
A equals 2. Did I do the 1/2? Oh, I did do the 1/2. I got scared. I thought I forgot the 1/2. 1/2 r squared theta 1/2 times 11.2 times 205 degrees times. Oh, you know what? That happened to me today.
I did the same thing.
I did that. I messed up the squaring in another problem. Exactly the same idea. 205 degrees times pi over 180 degrees. And that's the exact answer. Sure, I could clean it up if I wanted to, but I don't want to clean it up. If that's the exact answer, all I got to do is put square feet, and I have a good answer. I would accept that answer. But a lot of people like the estimated. Let's just give the estimated once with pi and then one without pi. So let's keep pi as part of the answer. So you're going to have to type in all of this, all the way to that, and then what you want to do with that answer is you want to take that, divide by 180, and I'll take it off of here. There you go. Does that make sense? That 180 can go underneath all of that, and then you still have a pi.
Yeah, this is not pretty.
How much?
I don't know if I did it right.
Well, we'll see if we get a second person, but I do appreciate everything you have done, Hema. 6 point what? 6.377. So let me just go 6.4 pi. Did anybody else get a 6.4?
When typing in the equation?
No, she typed in 1/2 times 11.2 times 205. She took that answer, divided by 180, I hope.
Yeah.
What? She got a 6.4.
Yeah, I got the same thing.
Okay, we got 2 people. We'll call it a deal. Now.
I got a 20.
Did you type in pi or did you keep the pi out?
Okay.
You multiplied by pi.
I added pi to the 2 of pi.
Oh yeah, but we didn't do pi yet.
We didn't do
Now your next answer, Adam. You said you took this. Now I like what Adam did. It's not a really good idea to take pi times 6.4. You're better off using the whole answer with the pi in it. What do you get?
I got 20.36 or 0.036.
I'll go 0.4.
Oh no, it's 0. It's 0.36.
Oh, 0.4 then.
Wait, what? How did you guys get the answer?
Did you go 6.4 times pi or the original answer you had?
Oh, I did the original thing, so it's a 1/2 times 11.2 times 2 of pi over 1.
You see what I have shaded? He also multiplied by pi.
Yeah, I got that too.
Next, this is
Rebecca to save the day.
Oh, yeah.
Are we not supposed to square it?
no.
No.
Yes, you are.
Where?
What? You got rid of the square.
Really?
No, I didn't get rid of it. I wrote it in.
Where?
Right
You
here.
didn't score the 11 score.
I wrote it
I
in.
said square it. That's why I was like,
I thought,
how did you guys
scratched
get
it out.
No, I didn't get rid of it. I said I forgot it. And Jonathan said, you forgot the square.
Don't forget the square.
I thought it was in red and then
You didn't do the square?
I got the square.
Okay, I forgive you all.
That's why I was like, what?
You know what I don't like? That you all had Jonathan become right.
Wait.
I wanted for once someone to save the day and say, sorry, Jonathan, not today.
So what did you get, Jonathan? 70?
All right.
71.43.
Yes.
It's like you put it in red
Oh,
and then you put
God.
black over it. So
Yeah, I know. You're right. Well, I'll take the heat. 21 what?
No, it's 71.
71 point what?
4311111.
431 pi.
Hi.
You guys, here's an idea. If you use a lot of decimals with the pi in it, then the next answer, I think you're okay just to go 71.441 times pi. Go ahead and take, or leave it in your calculator and just say times pi. Leave it in your calculator and go times pi.
Oh, we have 5 minutes.
Oh, Vice
Can we do 14 minutes?
Also, why did you round up? 71.43.
I just said 441. Go ahead and times pi. Somebody.
71.441 times pi is 224.4385.
44 feet squared.
Is that it?
Yep.
Alright.
Oh, here's radians. Thank God. We can do these fast. It's already in radians. Look how much easier it is.
Alright.
Area equals 2. 1/2. Did we have the 1/2 in that problem?
Yeah, we had the 1/2.
Okay. 1/2 times 7 squared. That's the square I missed earlier. Times theta. 2 pi over 3.
I got a 51.
So that's 49 over 2 times 2 pi over 3. That would be 98 over 6 pi. Yes, no?
49 over 3 pi.
How much now you're changing it?
Wait, what?
Where do you get? I got 98 over 6.
I divided by 3.
Oh, so what'd you get?
98 divided by 3 is...
30.
I got 49.
No, 98 doesn't divide by 3.
I got
Weird.
a
How did I
51.
get 49?
You can divide it by 2. All right.
Wait, so I got a 51.
All right, next page. Do you want to do even, odds, or multiples of 3?
Multiples of 3 is really fast, isn't it?
Evens?
6, 9.
let's just do even.
Evens. Both pages. All right, guys. Bye-bye.